The domain of the natural log of x minus 1 is the set of x values that we can plug in to this function, so we must consider the restrictions that the natural log function has. For the natural log function to be defined, its input must be positive. The natural log of 0 is not defined, and the natural log of negatives is not defined either. Since the inside of the natural log function x minus 1 must be positive, we can write that in an inequality. Solving this inequality for x, we find the restrictions placed on x. If x minus 1 is greater than 0, we can add 1 to both sides of the inequality to find that x must be greater than 1. And that's the only restriction on x. X has to be greater than 1 so that this function is defined, so that the input of the natural log function is positive. There are several ways we could express the domain, x is greater than 1. We could just write that x is greater than 1. Or we could write that this is the domain, the open interval from 1 to infinity. We're using parentheses next to infinity, because infinity is not a number, so it's not in the domain. And we're using parentheses with 1, because 1 is not in the domain either. X can't equal 1, x strictly has to be greater than 1. We could also represent the domain visually with a number line. This arrow says that anything greater than 1, but not including 1 because there's an open circle, anything greater than 1 is totally valid to plug into our function. So using an inequality or interval notation, these are both good ways to express the domain, and if you're asked to express it with a picture, you can do so with a number line. Looking briefly at the graphs, this is ln x, but ln x minus 1 has a shift 1 unit to the right. This is what ln x minus 1 looks like. And you can see that we cannot plug in x equals 1, that's an asymptote, and we can't plug in anything less than x equals 1 either. The function is only defined when x is greater than 1.